All right, so last time we met, we had just got started talking about JDBC, how it's a library that allows Java programs to talk to any number of SQL relational databases, and it creates an abstraction layer so that your programs can be shielded from the idiosyncrasies of any particular vendor. Right? Presumably, you should be able to compile your code against a specific JDBC API, and all the details of talking to a specific databases will be taken care of by JDBC. Right? So you compile once, and you should be able to run anywhere. We talked about a little bit about the architecture. You have your Java application talking through an API to JDBC, and then JDBC translating that to talking to your database. This is the family of the libraries that we're going to compile against. They all live in the java.sql library. And typically we have the driver, which is the entry point to the library. And then from a driver, you get a hold of a connection that is a live connection to a database. From the connection, you can create all sorts of statements, like an update statement, a delete statement, an insert statement, a query statement. And then you can execute those statements against a database. If it's a query, the query returns a set of rows that meet a particular criteria, your select statement. And the result set represents that set of rows, right, that you can then perhaps iterate over those rows. Let's look at an example. The general steps of interacting with the database is getting a hold of a connection, executing the query, iterating over that query, and then closing your connection. As a dependency, we are going to need to add to your project at least the MySQL connector, the Java connector. Right? This is the library that implements the JDBC API for the MySQL vendor. Each vendor will have its own implementation. Basically what they do is all these vendors, what they do is that they compile, they implement all the interfaces for the JDBC API, and so that they behave the way they're specified in the JDBC specification. They'll go out of their way to implement additional features that go beyond the specification, and they'll try to entice you to use some of those features that are specific to that vendor, with the idea that if you step beyond what the specification says, then you start becoming more and more dependent on that particular vendor, right? So they want you to stay and be a repeat customer, right? And that's the whole point of using JDBC, is that you don't need it to be you don't have to commit to any one particular vendor. So a very quick example is that you first do at runtime, you find the driver that you want to use depending on the vendor that you want to talk to. In this particular case, we are connecting to MySQL's JDBC driver. Notice that this is resolved at runtime, not at compile time, right? So your code presumably would be independent at compile time, right? You only become dependent at runtime when you pass a URL or the string that it's going to implement your particular JDBC driver. But notice that typically you would not provide a string with the actual class, right? Otherwise, you would be as dependent on the driver itself, right? Because this string is specific to that particular vendor. If you want to change vendors, you would need to come in and modify this string, right? So typically, what these strings are maintained in a separate file, perhaps a properties file or an XML configuration file, right? And they're read in from your application at runtime, yes, and then those strings are then used to instantiate the driver. So here's a simple example, right? We're hard coding it inside of the code, right? But typically you would not do that. So this class.for name instantiates the driver. That driver instantiates a static instance of the driver for that particular vendor, and that instance implements the class driver manager, the static class driver manager. which is the entry point to the API. Right? Each one of these classes, a driver manager class here, would be implemented by a MySQL implementation. Right? But your code should not compile against the native, the low-level MySQL classes. They should always compile against the interfaces, right? So that your code is independent of the actual classes that implement those interfaces. Okay. So yeah, so that driver manager is java.sql.driverManager, right? Not com.mysql.yada-yada.driverManager, right? So that's a. But underneath, it's actually implemented by a MySQL instance, all right? But your code is independent of that, which is pretty cool. Once you have the driver manager, we can connect using a connection string. This connection string is specific to the vendor, right? So the vendor provides the syntax for that URL. They all start with JDBC, a unique identifier that identifies the vendor. Right? In this case, it's MySQL, or it's Oracle, or whatever other vendor you're using. Right? In this particular case, it's MySQL. Again, this string also you would not typically include it as part of your source code. Right? Instead, again, it would be part of some configuration file, some XML file, whatnot, that you read it dynamically into your code, right? So that you know what the URL is. So you can configure it outside of your code as opposed to having it hard-coded in here. Make sense? Otherwise, you would be, if you want to change vendors, you need to recompile. You need to change it here and recompile. It makes no sense. So this is running locally. This is the port, the name of the database, the schema. Then again, username and password, typically, again, not in the source code. You would have it in some environment variable or something. Once you have a live connection, notice that the driver manager is used to get a connection to a database that is of type connection. That is java.sql.connection, not MySQL connection. This represents a live connection to a database. The database has given you a resource that it's live. You have a live network connection. Once you have that live connections, you can instantiate a statement and provide a SQL statement that you can then provide and execute remotely. This statement we created using .createStatement and then provide the string that we want to execute. In this particular case, we're querying the database, so we're expecting a result. So the statement has functions that allow you to execute a query or execute an update. In this case, it's a query. So we provide the SQL, and then we can iterate over the result set. The result set is represents the rows that come back that meet the criteria of your query, right? And it gives you an API that allows you to iterate over that result set. Notice that the way we're iterating over it is that we're repeatedly calling result.next, right? So that .next returns true as long as there are more rows to iterate over, right? When there are no more rows, it returns false, and you will fall out of the loop. Okay? Now, even though it looks like we're iterating over the rows, you shouldn't think of this result set as if it were an array or some collection, right? In the sense of collections, the way we think about it in object-oriented programming, right? In a regular collection or array, all the items, all the instances live in memory, yes? And we iterate over that list of items in a collection. Make sense? Right here, we don't have that because these rows could be hundreds of thousands of rows, right? The query could return all the students in a university, 40,000 students. So it would make no sense to try to instantiate 40,000 instances in memory, right? We would run out. It makes sense when you think about it in a relational database, when you're interacting manually with a database, but it makes no sense when you're interacting with it here at the programming level. So this result set is a pretty smart object. What it does is that it gives you the illusion that it's an iterable data structure, but it really what it does is that every time you do a next, it goes and fetches the next row from the database, right? And so it has a live connection to go fetch the next row, and then it gives you direct access in your program, right? It'll do some optimization, since it's very expensive to do network connections every single time for every single row. So it will do some caching. So instead of fetching one row at a time, it'll fetch maybe 10 rows or 20 rows or 100 rows at a time, right? So it'll go fetch 100 rows. It lets you iterate over those rows, and then when you're done, when you're almost at the end, it'll go fetch some more, right? And it'll give you the illusion of continuous iteration over the entire data structure. Make sense? You can configure you can optimize the size of how much you want to go fetch every time, right? The bigger the cache, the riskier it is that you're working with stale data, right? That if you fetch 1,000 records and you're iterating slowly through them, it could be that somebody is updating the data underneath you, right? And you're working with something that is cached in memory that it doesn't necessarily represent what's actually in the database, right? So you have to be careful and fine-tune what you actually want to do. Anyway, so once you have the row, you can now interact with the result with a particular row that you're pointing at, and then retrieve each field in that row, right? By using various get functions like getString, getInt, getDate, there's many getters that allow you to retrieve each field by name or by index, right? So you can find the first, the second, the third item. Also, another point here is that when the result comes back from the database, there is a cursor that keeps track of what row you're currently looking at. Okay. That cursor is not pointing at any one row at the beginning, right? It's pointing to a position that is called before first row. So it's not pointing at the first row. Not until you do that first dot next, right? Does the cursor advance to the actual row, all right? So you should not try to interact with any particular row until you do a dot next. Right, the dot next puts you at least at the first row, and then you can continue from there on. Make sense? This is especially important when you're expecting a single record. Like, for instance, I'm looking for somebody's by ID or by credentials, and it's one single person, one single record. Right? So you should do a dot next to put the cursor on that record, that single record, and then you can interact with that record. Make sense? So typically you put it like in an if. If result.next, then you can interact with it. Okay? And we'll play around with that a little bit. And then don't forget to close all the connections behind you. Since these are live connections to a database, if you don't close them, at some point you're going to run out of them. Right? The database only has a certain number of connections. Typically, you would use a caching mechanism like the assignment suggests, where these connections are pooled, right? And anybody that needs a connection, then it can draw from the pool of connections. So typically, the server would start up at boot time. It creates 10 connections, 10 live connections, and it puts the connections in a pool, right? And then multi-threading, when threads are running, they can ask for a connection from the pool and says, hey, I need a connection, and the pool is given to you. The connection is given to you. You use the connection, and then you release it, and it goes back in the pool for other threads to use the same thread from the same pool of connections. Connections are very expensive, right? So typically you don't want to instantiate, get a connection, and then when you're done, throw it away, right? They're very, very expensive. So typically you want to pool them. So yeah, here we're just closing it, right? And nevertheless, when you're done, close the connection. Property as an option to provide multiple properties. This just goes through each one of what we just mentioned. If you're going to execute an update, like an insert or delete, instead of execute query, it's execute update. Right, and then you provide the string for that update. These execute updates return an integer, telling you how many records were affected by your update, right? And you could use that for validation and whatnot. And again, don't forget to disconnect. This just points out the fact that cursors are positioned at 4 first, right? And you have to advance the cursor. Metadata allows you to query the database about the name of the table. You can ask the name of the fields. You can ask what sizes each field is, what data types there are. You can ask about metadata about the table that you're interacting with. Okay. All right. I'm going to leave the example for last, and we'll build something.